This time we have a problem which has power related to the voltage and also the resistance. So suppose that we have a power, these are given quantities. A power is specified as 100 watt. This is delivered to a certain resistor. So we have a resistor with a resistance R. And the applied voltage is 100 volt. So this is 100 volts. Power, of course, watt. So the first thing is we have to determine what resistance would that be. And the problem goes on saying, suppose that the voltage is reduced by 10% to 90 volt. So we have P prime, the new voltage is 90 volt. So it is reduced from 100 watt, reduced from 100 volt to 90 volt, which is a reduction by 10%. If that's what it is, the problem is asking by what percentage is the power reduced? Okay, so that we have to find the new power, and then we will figure out by what percentage, so delta P over P in percentage. Delta P, that's a change in the power, P times 100. So that 100% equals what? So if we go back to the relationship connecting power, voltage, and resistor, what we know is the power consumed by a resistor is given by voltage times the current that's passing through it. And from Ohm's law, the current is voltage divided by resistance. So if we combine these two expressions, we end up finding power equals voltage times voltage over resistance, which is voltage squared over R. So based on this, we can write resistance is square of the voltage divided by the power. In our problem, the given quantities, based on the given info, we have resistance R equals P squared. That's a 100 squared divided by power, which is 100 watt. So as we divide, this is in ohm, meaning our resistance is 100 ohm. So that's one of the tasks for us to determine, which we did. So next, the new power is given by the new voltage square divided by the R, which is found. The new voltage, of course, is 90. So 90 square divided by R. So this will be 90 square is 8100. So as we cancel the hundreds, we have 81 watt. So the percentage change is delta P over P times 100% gives us delta P is 100 minus 81 divided by 100 times 100%, which is equal to 19%. So that is our result. So to recap, we had a resistor which has a resistance R that we are supposed to determine. The given set of information is the fact that the power is 100 watt, which is the power consumed by this resistor when we apply a voltage of 100 volt. So based on this info, we have to determine what resistance would that be. Once we know that resistance, and assuming this resistance stays constant, the new power is 90 volt, for which we have to determine what is the new, did I say new power? New voltage is 90 volt. Uh, the new power has to be determined. Once we know it, our hunch is the power is lesser with the lesser voltage, of course. If the voltage is reduced by 10%, by what percentage the power is reduced? So it turns out the power is reduced by 19%. So that's pretty interesting. The reduction in the voltage is 10%. The reduction in the power for this case is 19%. Quite interesting conclusion. I hope you enjoyed this problem. I had a wonderful time talking about it. So take care. Have a good one.